So if you're planning on watching there, you can dial in over there. It's just loading, so I'll just give it a moment. There we go. Okay, so welcome everyone. Thank you very much for joining again. As I mentioned on LinkedIn, there's quite a number of people now registered for this event. So if you have any questions, make sure you get them in early. I'm going to give the usual introduction while everybody has time to join, and then we'll kick off with the session and the Q&A. Let me just activate the Q&A now. Yeah, so Q&A is activated. If you have any questions, just pop them in the Q&A and I'll answer them after the introductions. If somebody could just let me know in the chat if you can hear me okay and you can see the screen, or doing a thumbs up. Okay, so welcome everyone to the, just double check. Yeah, welcome everyone to the Process Safety with Louise sessions. This month we're going to be talking specifically about nitrogen, but you're more than welcome to ask any questions about process safety. We've made these sessions as open as possible to help you guys get access to advice when you need it. If you guys have something to add to the answer to the question, please feel free to add it, and just be mindful of what you say. Great to see you too, Pier Paolo. So remember, this session is being streamed live to YouTube and it will be available for playback on the YouTube channel. So just be mindful of what you say and be respectful. Everyone who's attending and myself, we're all giving our time for free, and we're here to help one another and foster good relationships within the process safety. So what is Process Safety with Louise? It's a place to get access to industry experts. Sometimes it's just me, but as always, the participants always add a lot of value. So if you're here to offer your advice, that's great as well. And sometimes we have a guest, like last month, we had Lorraine come and she gave us some advice about human factors. Typically, it's the first Wednesday of each month. We did 8 p.m., 7 a.m. and noon. 7 a.m. didn't work so well for me, so we'll probably stick to noon and 8 p.m. If you have any preferences, send me a message on the chat, or send me a message on LinkedIn to let me know which one's preferable. It is available for catch up on YouTube, and you can submit your questions beforehand. And I've had one of those questions today via email, so I'll be answering that on the session. And it's a place to share best practices for all of us to learn. Every time I run one of these, I learn myself. So don't feel like you are coming here just to share, or you're coming here just to learn. We're all here to learn from each other, and we all have different experiences, and so we can help each other succeed. So we're going to start the session in earnest now. What's the agenda for today? We started about 12:30. I'm going to do an introduction and a safety moment, and then I'm going to open the floor for questions and sharing, and then we'll wrap up just before 1:30. So, introduction to myself. My name's Louise Whiting, and I have over 11 years of operating and project experience with 2 major oil and gas operators. For the last nearly 2 years, I've been running my own business, providing professional process safety services globally. And what I'm doing, we've been running these process safety forums now since September last year. And there's quite a number of those available for playback on YouTube. The aim of this is just to share best practices and give people a chance to ask questions which maybe they don't feel they can ask in their organization, or have some advice on something which they're working on if they don't have access to a good process safety network. So I mentioned that today's example is going to be nitrogen, and I'm going to play a little video from the CSB because they've got a really great video on it. And then I'm going to reflect on some research that I did for the article on nitrogen. There are a number of nitrogen incidents, and they keep happening. So it's pertinent to talk about it now, especially as we're approaching the turnaround season, when we're going to be pressure testing vessels, where we're going to be purging vessels, ready to bring it online. This is a really good time to refresh our memories on the safeguards that are needed to work with nitrogen. So I'm gonna put this on play. Paolo, if you can just give me a thumbs up to let me know you can hear it. No? Okay. Let me pause this and I'll do a new share. Share sound. Okay. Great.
On November 5th, 2005, 2 workers died at the Valero Energy Corporation refinery in Delaware City, Delaware. They had entered a reactor vessel, a confined space that was filled with nitrogen, an odorless, invisible gas. The accident occurred during a maintenance operation at the 5,000-acre facility, which processes 180,000 barrels of crude oil per day. The complex is one of Valero's 18 U.S. refineries and has 570 employees.
From the moment a person first goes in to an oxygen-deprived atmosphere, they are effectively impaired. And when the oxygen-deprived atmosphere begins to enter the lungs, the oxygen in the blood that's going to the brain starts to fall. That affects the brain's judgment, it affects coordination, it affects the ability to exert strength. They fall down, fall unconscious, or their judgment is so impaired that they can't find their way back out, and they die.
Valero's hydrocracker reactor number R1 was shut down for maintenance. A large pipe elbow had been removed, creating an opening surrounded by large steel bolts in the middle of the platform. Workers had wrapped red tape around the bolts and covered the opening with plywood and plastic. Nitrogen flowed into the reactor and exited from the covered opening. Nitrogen is invisible, but it is colored light green here for illustration. Workers had attached a sign reading, "Danger, confined space, do not enter without permit." A crew of Matrix contract workers had received a Valero-issued permit to reinstall the pipe elbow. The Safe Work permit did not warn the crew that the reactor was filled with nitrogen. In fact, the permit stated, quote, "Nitrogen purge NA, not applicable." 2 contract workers removed the plywood cover and cleaned the ledge around the opening. At about that time, a 3rd worker noticed a roll of duct tape lying 5 feet down inside the reactor. This presented the crew with a problem. The tape would cause the reactor to fail Valero's cleanliness inspection, and they would not be allowed to reinstall the elbow until it was removed. However, entering the reactor to remove the tape would require obtaining a specially trained and equipped crew and a confined space entry permit from Valero. That process would take many hours and delay the installation of the elbow, which was to be completed before the end of the night shift, now half over. To avoid the long delay, one worker stood near the opening with a long, flexible wire and made several attempts to hook the tape. But he was unsuccessful. What seemed like an easy task just wasn't working. Most likely, the worker then got closer by sitting on the ledge of the opening with his legs dangling inside. But he still could not remove the tape. Based on the evidence, the CSB developed 2 possible scenarios for what happened next. In the first scenario, the worker lowered himself into the reactor to quickly grab the tape, relying on his foreman nearby to insert a ladder so he could climb back out. But after lowering himself into the reactor, he inhaled the nearly pure nitrogen inside. Deprived of oxygen, he quickly collapsed. In the second scenario, the worker on the ledge leaned over the opening, trying to get closer to the tape. At that point, he either accidentally slipped into the reactor, or he breathed in the oxygen-deficient atmosphere just above the opening, lost consciousness, and slid in. What happened next added to the tragedy. An eyewitness saw the foreman and the contract administrator peering into the reactor. The stricken worker was lying unconscious inside. The foreman quickly inserted the ladder into the reactor and climbed down to help his fellow worker. But without a breathing apparatus, he too collapsed from the lack of oxygen. The contract administrator declared an emergency on his radio. Valero operators then sounded the unit alarm. When company emergency responders arrived a short time later, They saw both victims lying motionless inside the reactor. A handheld meter inserted through the opening showed less than 1% oxygen, a lethal atmosphere. Wearing supplied air breathing equipment, the responders entered the reactor. A rescue hoist was used to remove the workers. It was now almost 10 minutes since the first worker had collapsed. Attempts to revive the men were unsuccessful, and both were later pronounced dead at the hospital.
This video shows the inside of the Valero reactor where the accident occurred. The roll of tape still visible just 5 feet below the opening. It's a situation where a worker might be tempted to believe he could quickly get in and out to accomplish what appeared to be a simple task. But safety experts warn that would be fatal. Nitrogen gas hazards are not limited to the inside of confined spaces.
A person who's leaning over, for example, with their face close to an opening in a vessel with nitrogen under pressure is not going to be breathing the regular concentration of oxygen in air. That can impair judgment, and it can also cause the person to pass out.
Warning signs and barricades are additional protection for workers tempted to enter low oxygen environments. The CSB found that there was a confined space warning sign posted at the opening of the Valero reactor. But it was only after the accident that the company put up a barricade around the work area with a sign reading, "Danger, nitrogen inert gas purge in progress. Oxygen deficient atmosphere. Do not pass this point without authorization." When a worker does enter an oxygen deficient confined space and is overcome, it can set the stage for further tragedy, as other co-workers attempt rescue without proper breathing and rescue equipment. This can lead to multiple deaths.
It's particularly sad because when an incident like this happens and you have a man down, other workers invariably feel a very human urge to rescue the co-worker. So they run into the situation very often without getting self-contained breathing apparatus, without getting an air supply, and fall victims themselves. It's not a question of the worker's judgment, it's a question of the worker's training.
Okay, so the hazards of nitrogen are real, and they are very similar to toxic gases as well, where we typically see more than one fatality, even though the initiating event is only a single person being exposed to the gas. It is human nature to want to go in and rescue colleagues, to go and help. But unfortunately, in the event of nitrogen atmospheres and toxic gas atmospheres, this can be fatal. So I had a look for nitrogen incidents because I know that there was one a few years ago in Egypt, I think, where 4 or 5 people died while they were doing some preparation work for returning from a large maintenance event. Nitrogen, they had nitrogen loss of containment. There were some people working inside a confined space. Nitrogen depleted the oxygen in the atmosphere, and they succumbed to the depleted oxygen atmosphere. When I had a look through, there was an interesting link from the ICME, which had a list of incidents, more than 450 incidents, and at least 20 of those had reference to nitrogen. So nitrogen being used as the incorrect gas for breathing apparatus. So instead of putting oxygen on, they put nitrogen, and damage to the lungs. There was nitrogen in confined space, nitrogen entering in a confined space where it was not intended to be entering because it was venting from another location. So I've written an article which I'll publish later today or tomorrow on using nitrogen in temporary arrangements, which is probably what you may be doing if you're in the Northern Hemisphere at the moment, as you're coming out of large maintenance turnarounds. Does anybody have anything else they want to share on nitrogen now? Okay, I'm not seeing any questions or anything come up in the chat. I had a question on email, And so somebody wants to know how you can use equipment count in quantitative risk assessment. Equipment count can be useful, for example, for number of flanges. So that can modify your leak frequency. And it can also be used when you're laying out the quantitative risk assessment. If you have 3 vessels adjacent to each other, then you would obviously need to replicate the scenario at each of those 3 locations so that you can see how it would impact the occupants which are nearby to those locations. I'm not sure if that's answered the question fully, but you really need to be understanding using a event tree and a fault tree to understand what's going into your quantitative risk assessment. And once you understand all of the events, you can then figure out how many of those potential events there could be using a failure frequency. Say, for example, for flanges, you know, you have 150 flanges in the area, then you can maybe split it into different types of flanges with different pressure ratings inside or different material inside, and then you can go from there. Okay. The last couple of weeks, well, at least the last month, have seen a large number of process safety incidents, and as always, the thoughts are with the family. As always, all incidents are preventable, and we can't know exactly what the cause of those were, but at least some of them are related to maintenance activities, especially given the time of year. There's a comment comes through on the chat to say that it seems unusual that in the video they were unaware of the confined space. The tape and the covering would have been sufficient to question the entry permit. I think people always aim to do the best, right? They always aim to take the least amount of time to do something, to be able to achieve the goals of the organization. For example, there may have been pressure to start back up and start back up in a certain time. They saw the role of tape. They saw the prevention to enter, but they just thought that as they were only going to be there for a few seconds to pick up the tape, everything was going to be okay. And that obviously is a big mistake. As the gentleman said, when you start to have that deprived oxygen, you can have impairment to your judgment, you can lose your strength, and then typically, you know, somebody will come in after you. So if you're thinking of going into a confined space and you don't have a permit, you haven't done oxygen checks, and you don't have an oxygen monitor on, and you don't have a rescue team, and you're not tethered, just don't, if you're not worried about yourself, you're not worried if you're going to go home, just think about your colleagues, because at least one of them will come in after you and try to rescue you, and they will also be taken from their family. So with these nitrogen events, there was a big event in Dubai maybe a decade ago. I think there were 4 people who went into a well bay area. It had H2S in. The first person went in, he fell off the ladder. The second person went in because they couldn't figure out why he might fall, and then he fell ill. And then another 2 people went in. The work party was 5 in total. Another 2 people went in to try and save those 2, and they also fell ill. And it was only the final person who luckily managed to stop himself but raised the alarm. Unfortunately, when they arrived, nobody could save them. They were already fatally wounded. So it's important to try to train people that if somebody falls down in a confined space, even if you don't know that there's a toxic gas there or that there's a deprived oxygen, assume that there is. Okay, so there was another incident. I posted a video and I can post again. Was a mushroom composting facility. They'd made a change to where they were pumping. They put an enclosure, and then when they were trying to clear the inlet of the pump because it had some debris from the composting, they opened the flange, and unfortunately there had been some anaerobic respiration, and there was H2S. They'd done this many times before. it's only mushroom compost, right? There's nothing to worry about. Unfortunately, because they put the enclosure around the pumps, that kept the H2S confined, and the person who was intervening fell down, and then there was another 4 people who went into the confined space with him. And it wasn't until the first responders arrived where they said, actually, nobody else should go in there because we suspect there's a toxic atmosphere. Okay, so the main thing is just to train people to recognize that if somebody falls down in a confined space, not to assume it's because they're having a heart attack or because they're potentially ill, to assume that it's because of a reduced atmosphere or a toxic atmosphere, and to, as quickly as possible, get help. If there is, are there any other questions coming through? So this is your time, guys, to ask questions. And if we don't get any questions, I will wrap up early, but I'll give you guys some time to ask questions. There's also, just before Christmas, I believe there was another nitrogen incident, and that was in a poultry factory. They changed the method for freezing the chicken from, I believe it was electrical to nitrogen based. And in doing so, potentially didn't assess the hazards as well as they could have. And they had loss of containment of nitrogen within the building. And unfortunately, there were several fatalities from that, where people were exposed to a deprived oxygen atmosphere. Does anybody have these type of atmospheres at their facility? Do you know how to identify a confined space? Or is there anything else that you guys want to talk about where you need help on a project or with a problem that you're working with? I'll give you a couple of moments. Okay, so I still haven't received any questions. I know there's quite a few people online. So if any of you have any questions, please, I'll give you a few minutes to type them in. So I've had one on the chat. Can you please explain a little bit about reliability calculations in process safety? There are a lot of people who are very interested in reliability calculations, but for me, the reliability calculations are most useful for planning investment and managing asset risk. So for example, you can have a look at your process, you can put the reliability of the pumps in, the vessels, and you can figure out where you have your weak point in your system to increase your uptime, i.e. your production time, and therefore managing your asset risk. I prefer not to use reliability calculations in process safety because it doesn't necessarily introduce a hazard if something breaks down, but it can introduce a hazard if something doesn't meet its design intent when required. Okay, and that's quite different to the reliability. So what we're looking for there is its probability to fail on demand. So when it's demanded to be actioned, that's when we want to be looking at it. The other thing is reliability calculations are typically using failure data for something that is operating continuously. And the safeguards, which are the things that we're interested from a process safety perspective, they're actually very low demand. And so the failure frequency is not the same and the calculation's not the same to identify the availability of that item. So if we're going to be doing some calculations to determine the suitability of our safeguards, I would move away from the reliability calculations and move towards something like a layer of protection analysis or a quantitative risk assessment. Using your event tree and your fault tree. So your fault tree to identify all the potential faults, and your event tree to identify all the potential consequences, and then looking at the likelihood of each of those based on failure data, and it's failure to deliver the required function on demand. And then where you get that data from, again, make sure you validate that that data is not too conservative. If you don't have anything specific, or you're a bit concerned about the conservative nature of it, resort back to some of the resources like the CCPS book or like the Orange book in the UK. Those can help you more adequately, more conservatively assess the probability of failure on demand. With reliability, you're looking for sort of failure per 1,000 hours, which is a bit different. Can I send some sources? So I'm just going to get a couple of sources here. So these are the ones I use. With LOPA, just try and keep it simple. But there's this one, initiating events and independent protection layers. And then there's this one, which is enabling conditions and modifiers in LOPA. And so that has quite a bit of data in it, and it can cover most scenarios. There are also some ignition probabilities in various different sources. Depending on the fluid you're using, you might want to use a different ignition probability to the one stated here. And also you need to validate these after some time. So you might use these for your initial assessment and then go through and design your system appropriately, either to SIL 1, SIL 2, SIL 3, whatever is required according to your assessment. And then operate your facility for 5 years. And after that, revalidate that your system is not failing more frequently than you have assessed in the calculation, because you definitely don't want to be in that situation where your system is failing more frequently than you've estimated, because then your system will be underprotected. And by failing more frequently, that could mean that the initiating event is occurring more frequently than you thought. So for example, if it's an overpressure, if there's a potential for a valve to close, causing the pressure to increase, if that's happening at a higher frequency than you anticipated, you might have said maybe once a year, and actually because of fire and gas faults or because of human error, that valve is closing once a month. Well, then you've really undermined the safety calculation that you've done in your LOPA. So it's really important to, if you use something generic, which is fine, and it's good as a screening tool because LOPA is about screening, you use that, you calculate what things need additional attention, design those more in a more structured way, install them and maintain them, and then check. Always go back on the checking to make sure that it meets the requirements. I've got another question. If anybody introduces new equipment, where can we get the failure data? There's very little new equipment, like completely new equipment. So most of the stuff will be covered by the standard BPCS failure data, which is the basic process control system failure data, which is a 0.1 per year. But if you do have something which is truly novel, what I would recommend is that you use a conservative estimate and design your safeguards such that it can protect you against that conservative estimate. Not talking about being hundreds of times conservative, but if you think that the failure rate of this is 0.04, I would probably consider a 0.1 for the first year, and then you can then validate to see if that failure data was correct, the 0.04 over time, and then move towards that. A lot of systems that you install will be SIL 2 or SIL 3 capable, and therefore if you install that system, What you can do is, if over time you find out that it doesn't need to be as reliable as you initially thought, you can reduce the maintenance or decommission some parts of it, so that you can reduce your maintenance or lifetime costs. Okay. Does anybody else have any other questions or tips? So today we've spoken a bit about nitrogen. We've also spoken about reliability and process safety calculations in LOPA. And I've recommended a couple of documents. So I've got another question here. Right. So am I doing anything on hydrogen? Do I have any particular thoughts on hydrogen for small non-coma industries, as the various large players work to confirm the study, its transportation and use in natural gas? Hydrogen, just like any other hazardous fluid, needs to be very carefully managed. And hydrogen needs to be more carefully managed than natural gas because it has a much wider explosion envelope. So although you may not, it may seem like this is not true, because we do have a lot of fires in hydrocarbon systems, we do have a lot of explosions, but actually hydrocarbon gets very quickly too rich to burn or too rich to explode. Hydrogen has an enormous window, and it takes a very long time, or quite a lot of hydrogen, to be able to get too rich to burn or too rich to explode. It's also colorless, and the flame is colorless. So at least if you have a hydrocarbon fire, even if you didn't have any odorizer in it, you would be able to see the flame. Hydrogen, the same as methanol, it's an invisible fire. And so you can actually walk into a hydrogen fire without realizing you've walked into a hydrogen fire until your clothes are on fire. And then someone comes to rescue you. They can't see the fire apart from your clothes on fire. And you're getting into the same sort of situation as you are with toxic releases and oxygen deprived environments. So what I would say is, if you are going to be implementing hydrogen in your non-coma site, please just be very careful. Make sure that you do some proper risk assessment, and make sure that you train people. Make sure that if you have any confined spaces, that they are well ventilated and that there is detection in there for hydrogen leaks. Hydrogen is also a much smaller molecule than natural gas, and so therefore it doesn't take as much to initiate a leak. Personally, I have massive reservations for introducing hydrogen to facilities or homes where major hazard management is not very strong. So on a top tier coma site, they probably have all the processes and procedures to manage a new major hazard. They have the proper training, the competence assessment, they have the barriers, they understand about safety critical elements, they do all of those good things, and they probably do them quite robustly because they have quite a lot of attention from the regulator. But if you are not handling these sort of high hazard items, just please be very careful. Get somebody who is competent in hazard identification and risk assessment to help lead you through the way, to make sure that you can explore the hazards which will be present at your facility. It's all well and good me saying, flammable, the flame is invisible, and so on and so on. You need to be looking at your facility. There might be nowhere where it could be on fire that somebody could walk through, or you might be able to provide some other means of protection. But remember, it is a colorless gas, it's odorless, and it burns without any visible flame. And so therefore, it is very easy to get escalation, as we've seen with the nitrogen and also with H2S incidents. Paul, I hope that answered your question. I know the HSC are doing quite a lot of work on the safety of hydrogen as well. So they've just issued a webinar, which they did earlier in the week. And that was a 1-hour webinar on the safety of hydrogen. If you are blending hydrogen with natural gas, that is much less risky, because you are already managing natural gas. It's a visible flame. It's already got an odorizer. That's much less. If you're using pure hydrogen, that's when you need to start. It's a different level of hazard management. So I've got another question. You mentioned ways on how to identify or manage confined spaces. Could you share a couple of examples? So confined spaces at your facility can sometimes be hidden, and I don't mean that you know, they're hidden behind walls or whatever, but what I mean is that you might think that you're not in a confined space because you feel like it's quite open, but actually there could be barriers on each side which could reduce the airflow in the area. The general rule of thumb is if you're not getting 12 air changes a minute, it's confined or partially confined. And then there's a second number below. So an example of one is when I was working in Iraq, we had big bunds around our tanks to protect adjacent waterways from loss of containment in tanks, but also to protect people from potential incidents which were outside the facility because it was close to the road. Unfortunately, they stopped the airflow quite effectively. And if we had any releases of any kind, even if it was quite a windy day, they would accumulate in that area because it was confined. So you were completely outside, you had everything open up and you felt like you were outside, but actually it was a relatively confined space and you didn't know that you were in a confined area. So that's what I mean about confined spaces can be hidden. They can appear open, but if there is an obstruction on one or more sides, and again, you might need to be looking at the bigger picture, just go and take one of the air meters. They're not expensive and you probably have them already at your facility to test HVAC. Go and have a look to see if the air is moving, right? If there are places in your facility where you get really hot or where people go to stand out of the wind when the weather's really cold, that's probably a good indication that could be a confined space because they're getting out of the airflow. So that's giving you an indication that it could be a confined space or a partially confined space. And then it's looking if there are any hazards in that area, which could result in a low oxygen atmosphere or a toxic atmosphere, or even an accumulation of gas, which could then result in an explosion. I hope that answers your question, Pier Paolo. I've got a question from George. Why do we seem to be experiencing more process safety risk management related catastrophic events than in earlier years, related not only to hazardous gases? So George, I've mentioned this a few times on LinkedIn, and I honestly believe that the change that we have undergone with COVID has been a massive impact on the management of process safety on a lot of facilities. Some facilities have been able to manage that well, but what I would caution is just because you haven't had an incident yet, it doesn't mean you managed to tick all your boxes and manage everything well. It just means it hasn't happened yet. And so if you haven't had something happen yet, use this as an opportunity to go and check your process safety management system. COVID has been a massive distraction for management, for people on site, for people at home. They don't have the capacity to think of the things they used to do before. People's mental stress is a lot higher. If you have a facility which has a high reliance on people barriers, then there is a potential that you could be at higher risk than other facilities. If you have a facility where there has been deferred maintenance because you couldn't get the number of people on site because of the COVID risk, again, have a check that you haven't left anything out and you might be leaving yourself exposed. And then things like management of change, HAZOP, hazard, LOPA, those studies I've also seen a lot of facilities defer because their preference is that they want to complete them face-to-face so that it provides the biggest learning opportunity for their staff because they can be scribes, that, you know, they can be more involved. You can go to the facility, you can see things, and those are all good reasons to defer. But if you have deferred, and for example, you made a change at your facility that hasn't previously been well assessed, that could then be waiting in the sidelines for you to be impacted. So for example, the algae polymers incident, which happened just after we started to lift, or after the world started to lift COVID restrictions, that happened for two reasons. One is because they didn't have sufficient inhibitor on site to manage such a prolonged outage, i.e. they weren't using the styrene monomer, and they needed that inhibitor to keep that tank safe, and they didn't have enough inhibitor. And number two, they had recently undergone a change in the way that the fluid was circulating through the tank, which meant that there wasn't good mixing, and so there was some stratification in the tank. Now, potentially they were distracted by COVID, or potentially they just didn't have the right people in that hazard risk assessment. If it had been time for their 5-year review, they may have been able to catch it before it had a major incident. Okay, so I think that there's a few different things in there, George, but definitely massive distraction for management and people on site as to focusing on the process. Process safety is already challenging for people to focus on because it's quite technical, and not everybody feels that they have the right level of competence to talk about it. Now you have something that's a common language for everybody to talk about, and it's managing risk and it's managing mental health, which is all great, but that can detract from your process safety management system. If you have barriers which are particularly human-centric, that can be a problem now. And if you've delayed any of your hazard risk assessment processes to accommodate for COVID, and that's ranging from hazard identification, risk assessment, or maintenance or inspection, that's probably also going to potentially cause a problem. And just don't think that just because you didn't have it, it's not going to happen. Use this as an opportunity to learn from others and take a proactive step. So George, I hope that answered your question. Those are just my thoughts. And I know that others have other views as to why we're getting those. And you're more than happy to, if you share those on the chat, I'll read them out. So in response to Paul's, I responded to Paul's question about use of hydrogen on non-coma sites, and he's agreed that on non-coma sites, small businesses and homes, he would be most worried and assume or hope seeing that the main players are considering your points. On color and smell, we'd be able to add something, for example, mercaptan, as we do with natural gas, indeed. So, I mean, I think it's just about the visibility of the flame, but again, probably something could be added to help manage that. And then there's the wider explosion and flammability window, which means that for a longer time, you're exposed to a potential ignition. Whereas with the natural gas, it's a much shorter time, even though there are still a significant number of incidents. I think there was something like, I said only 50% of incidents, 50% of gas leaks are detected by gas detection. The other 50% are detected by either ignition or operator rounds. So even if you have gas detection, doesn't necessarily mean it's going to be 100% effective. And then having that wider envelope for combustion can introduce significant problems. George added that potentially money could be a contributing factor to the process safety management. Yes, some sites don't need any excuse not to spend money on process safety, but COVID, if there was ever an excuse, COVID was a good reason not to spend money on process safety management. And so, yeah, if you were already at a facility which was predisposed to think that process safety is tomorrow's problem and not today's problem, then yes, COVID could have been a reason to defer that spending. And also there was simultaneous with COVID, there were some significant commodity price drops as well, which put a lot of pressure on industries. on their profitability margins. So not only did you have this massive distraction and cost associated with COVID, you also had the fact that places weren't bringing in the money that they needed, and so things would get deferred. Okay. So are there any other questions? I'll give it a few more minutes. All right. Okay, I've got another one. Noting LinkedIn comments from yourselves and others on water facilities, are there any thoughts on the explosions in the UK water facilities, e.g. Avonmouth in December? According to local media reports, not forthcoming, expect to be made public on that one. So the report that I saw was from the ICME shortly after the incident, and it suggested that hot work could have contributed to the incident at Avonmouth. One of the most common problems with instrument air, water, nitrogen, I don't know, bleach, you assume that because it's a day-to-day thing that you see all the time, that it doesn't have significant process safety hazards. But actually, water, if it's at high pressure, it can. And also the anaerobic respiration in water can produce byproducts such as H2S, or sometimes water can have come in contact with other fluids which could have flammable gases associated with it. There could be some decomposition of other things. There could be a layer of diesel on top, a very small layer, or a layer of petrol on top, which has been run off from somewhere where there was a spill, and that can create a flammable atmosphere. There was an incident that the CSB did a report on, and also is the same incident that was used this month for the CCPS, where they were busy welding, and it wasn't even welding on the tank. They were welding the walkway above the tank. So it wasn't even that they were working on the tank, but the tank was a water tank. But unfortunately, that water came with some condensate. And during the turnaround, the nitrogen system, which would have normally purged that, was switched off because that needed maintenance. The tank then had condensate sitting on top of the water. With the heat, it made a flammable atmosphere. With breathing in and out breathing overnight, it's drawing in the oxygen, and during the day it's expanding and letting out, and then allowing more draw in the next night. And so they had a flammable atmosphere in the tank. They had no idea they had it. And then as a result of the sparks which were on the walkway, that ignited the vapor space and caused an overpressure of the tank. Tanks don't have a lot of room for overpressure, so it doesn't take long between the ignition and the tank failing, and the tank fails very spectacularly, as we have seen in the video from America. This in the last couple of months, there was a video of a water tank flying with a single fatality from a gentleman who was located next to the tank, who died from the tsunami of water. But it doesn't take a lot to fail those tanks because they don't have a big design margin in them. So if you're working with water, nitrogen, air, or anything else you consider to be household happiness, please be careful, because they can have some hidden hazards in which you might not realize, especially when they're managed in these high pressure industrial applications. So I hope that answered your question. I can't definitely say what caused the one in Avonmouth because we don't have that information. But what I read in the ICME was the suggestion that could have been hot work around the tank, which is why the contractors were on the tank, which could have contributed to an ignition. Okay, so George has asked another question. How to protect our contractors who seem to be disproportionately more frequently victims of asphyxiation versus employees? Is this perception or correct? So yes, if we look back at process safety incidents, there is a disproportionate amount of contractors who are fatally wounded in process safety incidents. This could be two reasons. The first is that since the 1980s, companies have moved towards outsourcing so that they can reduce operational costs and only bring people in when required. Rather than keeping people on the books for the whole year, they just bring them in when they need them and then they let them go. So there are more contractors than employees in general on work sites than there used to be, say, 40 years ago. However, the second reason that it could be, and for me, this is probably the most likely, is because often we assume that because we're hiring a contractor, they are competent in their work to do that job, because we're paying for them to be the contractor and to be competent. And so therefore they should be competent and they should know things. Yes, they may know things about what they are hired to do or what their process is to do, maybe welding or whatever, and that's fine. They might know that. They don't know the specifics about your facility. And that's where you come in. But because you've already assumed that they are sufficiently competent, sometimes contractors don't get the same level of attention and training as operators. And contractors are in a high state of flux, right? They're always changing over. So if we were training contractors all the time, we might do nothing but train contractors. But if there are things where we need to have people who are trained for the hazards at our facility, we might want to be thinking about bringing that resource back into our staff base so that we can maintain that competence, or having an agreement with our contractors that they will use a base load of contractors who have an awareness of the hazards at our facility. So with regards to contractors, I think the most likely cause is that there is less attention to the training, especially the site-specific training of them, because they are coming in this sort of state of flux. And then also there's another aspect, is that you generally bring contractors onto your site at the most dangerous time to have contractors on your site, right? When do you bring contractors? During a turnaround, during a shutdown, during maintenance activity, when something's going wrong, right? When everything's running normally, you don't generally have additional personnel there because you want to be producing, you don't want to be doing these other things. So the very nature of the work that contractors do means that they're at more risk, because they are on your facility at the time which is more dangerous, which is startup, shutdown, transient operations. And then they don't know the facility and they don't have the same level of training as your facility, your operators on your facility. George, I hope that answers your question. And again, that's just my perception. I've noticed that in a lot of reports, I mean, for example, Texas City, all 15 people who died there were contractors. They were not staff of BP at the time. So yeah, that's what I've noticed in reports as well. So I've got another question about hydrogen. With regards to hydrogen, default explosion hatches might be a good idea as a mitigation to prevent overpressure in an enclosed space. What is your opinion? Yes, I think definitely we use explosion hatches or pressure relieving panels, which they're sometimes called, especially in offshore applications where you can't get the distance between personnel and the hazard. So yes, definitely this can be used for hydrogen, and this reduces the overpressure, but it doesn't stop the people who are in that area getting injured. So it helps prevent, say, the building, which is a few hundred feet away, getting injured, getting damaged, and the people in there getting injured, but it doesn't reduce anything in that direct area. If somebody is in that area when the ignition happens, they will most likely be injured, if not fatally injured. So yeah, and also when you are putting those explosion hatches in, just be a bit mindful of the weight and the direction that they're going to fly. Because the last thing you want is that your safeguard then ends up causing a fatality because you've not considered this 25 kilogram panel flying towards an office block. I've seen a few of the explosion hatches which are attached, so they don't actually travel anywhere. So that might be a good solution, but you will always have to consider the potential that the hinge might fail. And then I've also seen, if you have watched any of the Baker Risk videos, the way in which they actually create the confined space is by putting sort of cellophane, not cellophane, but something like that, which tears when the explosion happens. And so therefore it has no weight to it. So as it releases, it's fine. And we've also, I've also seen the use of gas curtains. So having a curtain in place to reduce the size of the gas cloud. So instead of the gas cloud being able to take the whole room, you put in a curtain, and then that reduces the chance for the gas to migrate into the much larger volume, which increases the overpressure. The problem with that is you need to maintain them, and you need to tell people why you have them. But the good thing about that is that if there is the overpressure, the gas curtain can just go away without injuring anyone as well. And then I've also seen the use of water to limit the size of a gas cloud. So if you have a gas detection initiating some form of deluge, which then limits the size of the flammable gas cloud, because the gas is absorbed into the water as it's flushing forward, which again is another way of reducing the size of the gas cloud, because the size of the enclosed volume, which is filled with the flammable gas, is directly related to the potential overpressure generated by the gas. Does anybody, oh, I have another question. Another question with regards to hydrogen. What do you think the use of CFD about risk modeling? So I think that there is quite a lot of data with regards to hydrogen. Hydrogen was used a long time ago in town gas. Hydrogen is used on a lot of facilities as a raw material or as a fuel. So it's not as if hydrogen is not used. However, you would just need to be cautious to make sure that the correct gas was selected when you did the consequence modeling, and that the correct dimensions and everything have been considered. But there is information out there, just making sure that you're asking those good questions from your contractor to say, you know, which model you're using. Are you sure you're using a model for lighter than air gas? Are you sure that you're using the correct explosion range or the correct flammability range? And are you considering, you know, wind in different conditions? Because one of the biggest things about risk modeling is that people often assume that it's relatively windy when inputting the data into the modeling. It's really important to have at least two cases. One is sort of your normal wind conditions, and the other one is a relatively still. Because if you look back at incidents, is also that there are potential for incidents to happen in the dead of night when there's no wind. So for example, Buncefield, the only reason that Buncefield incident was as large as it was because that night was particularly still. And so things do happen at the time which is least opportune for them to happen. So make sure you consider both. John, you've said something about open foam. Is that in relation to managing hydrogen explosions? So rather than to make sure that we're not having debris flying. Yes, yeah, okay. So I mean, there are a lot of solutions out there, and I think a lot of those are coming to the fore now. But I would just say that if you are not managing major hazards on a day-to-day basis, do not underestimate the effort and organizational resource required to manage those. It is much more significant than managing the hazards that you're currently managing at your facility. I'll give it a couple more moments. If there's any more questions, I'm more than happy to answer those. And then we will wrap up from there if everybody's okay with that. Oh, I have another question. So George says, thanks for your passion and value-adding contributions to prevent catastrophic process events that can kill, maim, and negatively impact families, communities, and environments. Thanks very much, George. That's the reason why I do this now. And I hope that by doing this, we can share these learnings worldwide so we can stop incidents happening in the areas where maybe the process safety competence is not as strong. And then also for networking and leveraging your competency and expertise to empower others to improve. Thanks very much, George. Appreciate the feedback. And then also there's another proprietary name for use of the blast panels for hydrogen. It's called blast foam. No, blast foam is being used to assess the physical effects of overpressure for hydrogen. Okay, well, thank you all very much for attending. Just as I mentioned, I've got, it's the wrong presentation. I've got a nitrogen article, which I'll publish either today or tomorrow. And then there's also, I just made a nitrogen checklist, which you could use on your facility if you were having some temporary equipment come in for the purposes of purging or pressure testing. So keep an eye out on the website for when that's available. I'll pop it on LinkedIn as well. So if anybody follows me on there, they'll be able to see. But thanks very much, everyone, for attending and for the really engaging questions. I really enjoyed these sessions, and I learned quite a bit about hydrogen as well today. So thank you very much. If there's no more questions, I'll give it a moment or two. Then I'm going to wrap up the session, and you guys all keep safe and keep in touch. If you have any questions in the interim, please don't hesitate to get in touch. And if I don't know the answer, we can leverage the network on LinkedIn and try and get you the answer, because I don't know the answer to all things, but we can try to get you the answer. Okay, well, thanks very much, everyone. Thanks, Paul, and take care. And I'll see you guys. The next session's on the 1st of September. I'm probably going to go with noon because it reaches the widest audience. So we'll see you again on the 1st of September at noon. And thanks, Pierpaolo. I'll get that article and I'll